Hello friends, thank you to joining me or this my set channel of retro coding. This channel will be my freeform experience about doing retro computing, especially on this field of coding the old machines. So for today's episode, I won't be long. I just want to show you how I built my station. Right. So on this screen, you may see that I am running a Windows 95. Right? Windows 95 that is released around 1994, which is running in pure pre-Pentium Intel, and as well as the 60 megabits of RAM. This is actually a high-end workstations during the day. So I want to actually experience how it was, or remembering how was I doing coding when I was using this kind of station. This is actually the downgrade of my own station. My first station was Intel Pentium Pro 166 megahertz with the same amount of RAM, so I downgrade a little bit and pretend I am a programmer from 1994. So what is in 1994? So let's see. Let's see the settings, right? So here, okay, let me wait. So in this machine, we have an i486 socket 3 with Asus PVI 486 SP3C. And I'm not using Intel, I'm using AMD M460DX4. I don't know whether it makes difference if I'm using Intel or not. And I set up a memory of 16 megabytes. Sorry. And also I'm trying to replicate as much experience, so I'm using S3 Vision 964, which is Diamond Stealth 64 VRAM. I tend to use a very common card. This is the most expensive card that day, running on the VLB bus. What is VLB? It is on my blog. I show it VLB in the full glory. As well as I set up a Voodoo Graphics, the first version, which is released on 1994 too, which is the high-end 4 megabytes Voodoo Graphics with 2 render threads, right? And also on the input devices, we are using standard PS2 mouse with 3 buttons like this. So it will have a wheel. So I want to be as bleeding edge as much, as high-end as much with if I was going to live on that particular time, right? So sound is very common to use on Blaster 16. I used that in 1998, so Sound Blaster 16 is the way to do with all the usual address, RQ, low DMA, high DMA, whatever. And network, I've never used network before, but I need it here. So we'll use the Novell Network 2000, which is pretty common during the day. We can also use AMD PCNet, but then the driver for Novell is usually stable, as well as it is emulated perfectly. Right. So ports I use to generate dot matrix. We won't do any printing at all. So just leave it like there. So for storage controllers, so this machine have storage controller. They have IDE controller, right? And then also FDD controller, floppy disk drive. And then because I want to be fancy, I pretended I was in 1994, so I use Boost Logic SCSI adapter to attach my zip drives as well as my CD-ROM, right? And then because, yeah, again, we pretend we are the rich guy in 1994, which do software developer, so it is then we have 3.5 inch to 2.88 megabytes for drive A and B. Other peripherals, I don't install anything, so that's it, right? The operating system that I use is Microsoft Windows 95 OS R2 with Internet Explorer, a very exciting Internet Explorer 5.5. So this is the newest Internet Explorer that can run on a 486 processor with 16 megabytes of RAM. So 16 megabytes of RAM. So I tried to create a machine that have 1,000 of RAM and try to build a program on top of it. Right. So what is the how we build program during that day? That day we have Visual Studio. The Visual Studio that is available that day is Visual Studio 5.0. Right. I want to use Visual 4, but it is so wanky. I don't like it. So I just installed the not really new like Visual Studio 6, but just one generation behind. As well as I install some DirectX SDK over here just to I want to create some kind of graphics later on. But now let's don't start with that. We start with the basic stuff first. Right. So this is the computer that is I want to use computer because it's emulated. So what is emulated that I use? The emulator I use is 86 box. Yeah. Okay, I need to turn it on first. I want to turn it off first. Wait. Let me turn off like real computer. See, it is very exciting. See, it's yeah, it is turned off, right? So I can close this thing. Why I'm using this? Because this is the most compatible PC emulator that I can find. So it is 86 box. I built it. It is running on Mac in the 2016 16-inch Mac, and I built it myself. If you are using Windows, you don't need to build myself. I use the last master. The last master build. Yeah. Last master build just November 6th, yeah, this morning. So not even this morning, it is just a few hours ago. And then I build myself by using CMake and Ninja. And then I have my everything is being saved on the machine, so I recorded on the folder in Win65. I will clear this one and show you the better command line to do it. So this will run, and then it will run the emulator with its full glory. Right? I don't like this background. I will move this to my second desktop. Right, so it's better. Right, so to see that it is 2022 Mac OS 10 Ventura. It's very exciting. Okay, so this is the startup. As you can see, it is Microsoft 95. I installed the Plus package just for old time's sake. We don't have Microsoft networking. And then listen to it. The startup sound. Did you remember that? If you haven't born, then you won't remember. Alright, so that is how the machine is starting up, and then let's see what can we do in this particular IDE. So I have installed Visual Studio 97, and then I also installed its SDK, but I also want to show you demo drive, Visual Studio, and then going to Visual Studio. Let me see. No, not this. Visual Studio Enterprise. Okay, so I am back. So this what I did just to mount the Visual Studio 97 ISO, so I can have the help working. Right. So I have created a very small what I call two small programs here. The first one is the the usual suspect, the hello world. This one is just a very simple hello world program. I just need to clean, and let's see how it is built. Right, so it's built, and you see you can build it. Wait for it. Yeah, it's a little bit slow. It is C++, and it runs on the 16 megabytes. Okay, it runs, no error, and it's really running, and then just show a hello world. Yeah, this dialog, right? So this dialog. So what does it means, right? By using this Visual Studio C++, Visual C++ IDE, we will build a Windows apps. Windows, not apps, Windows programs. Apps hasn't got the word hasn't got it didn't catch on back then, right? So in this IDE, actually it's pretty nice. Like this, you have the not autocomplete, but if you point out to one of the function, whether it is winmain, and then you hit F1, it will show you winmain, right? What does winmain means? And it will open the HTML help, which show you that winmain called by the initial point for Win32 based applications, right? So this is for this. Okay, and then for example, you want to know a message box, then there are C window message box. It is not that we want. It is from the MFC. So we want a plain message box. Yeah, this is message box, right? So this API called Windows API, and it runs for Windows 95 throughout modern Windows 11. You can take the exe and then you can run it on the modern Windows 11. It will run, no problem at all. This is the first hello world, and I will open my second project, which actually will be a baseline of the future project. Is the how we build a window, right? So you might think that, oh, building window now, if you are using .NET, you can just using WinForms and put there. Using Windows or using Windows plain Windows API, building Windows is little bit involved. It will tell you how to build, how to basically handle the message spam, and then the all window creation stuff. So to create a window, right? So let me show you how it will run. Okay, this is the window that we will creating, and then it will print the Windows 95 and the version number, as well as you can maximize, minimize, restore, and then the usual context menu over here, and then you can also close, right? So this is the window that is built by using this single main.c source code. I tend to use the plain C because C++ during that time is kinda useless. It's like an old C++, so I just use C. And then even like SNPrintf hasn't been there on the standard. It is underscored, so I need to basically tell that, oh, there is no SNPrintf, so I will use the underscore SNPrintf. Sorry. Okay, so to create this program, a Windows program architecture, or I might say, if you want to build a Windows program, then you need to have two function defined. First is the winmain. We already knew that before. It's just using message box as the entry point. So it's like if you're using Golang, there is the function main. If you're using Node.js, I don't know, it's like nothing, right? So if you're using Golang as function main, if it is you're using C and you run on Linux or Mac OS, then it is main, right? It is console program is main. For Win32 program, it is winmain. And then whatever over here is API entry. What does it mean? Let's see. Not fun. Which actually it doesn't matter. It's just only calling convention. API entry and callback is the same calling convention called standard call, which basically the callee, the function in itself will clean up the stack. What does it mean? It doesn't matter. Just put there API entry. The second function that you need to have is the window procedure. What does it mean? So open the window procedure. Simple types or just okay. No, it's not window procedure. So basically it is window procedure, and then window procedure means that it will call whenever a message comes to window, right? So a window has one window and the window procedure handling the message. So for example, right? So for example, if we have in this a win main, so we need to have a handle. Handle is kinda of a variable that will hold our window instance. Yeah. So in the Windows, everything is a window, including the button, right? This button, that button is window. Or in modern 2022, if you are using Flutter, it is widget. It's actually the same. And then message is to get, or basically to take the message from the message pump or message loop or even loop, right? So if you have even loop now, it's actually the same. Windows use that paradigm to build a window for Windows applications. And then WND class sec is the window class, which means that this window class describes how is your window, what is the name, and for example button, how it looks, and then how the basic behavior. So we know this structure is actually important for creating a window. We need to zero it out, so every member has 0, including the pointers. It will be null. And then first step is to fill out the window class. So we need to window class X, WND class X WC, and then we put the members here, right? So CB size is size of WND class X, style is CS H redraw V redraw, which means that when window is being moved, it will be redrawn. Right. So this, you see the artifact. This is the artifact of the window being redrawn. And then after that, WND proc, it is forward declared over here, so it will implement in the bottom. I will tell you what does it mean, right? So it will implement the bottom, and then after that we put the H instance. What does H instance means? H instance, before Windows 95, every application has their own instance of applications, right? So this H instance holds the pointers to that instance object, right? And then also this is LPSZ class name, which means that long pointer to 0 terminated string. It basically like this is 0 terminated string. And how this is long pointers? Yes, because it is far jump on pre-32-bit Windows. What does it mean, far jump? It doesn't matter anymore. It is, we are using 32-bit Windows. You can read our my past post about 16-bit, and or maybe in the next videos I will also tell you. I will also about in the next video I will basically tell or talk about the long and far pointers on 86 x86 platform. But just fill it with any random unique string over here, right? And then H icon and H cursor, which basically give the handler to icon and cursor, which means that H is an IDI application, mean that we will use this. This is the default application icon. On Windows 11 it will change. On Windows XP it will change to something different, right? And then also for cursor we can use the IDC arrow, which means that the cursor is the by default is an arrow. This is an arrow. Okay, all right. And then as of that we are using HBR background, which actually handle to brush to background. Each brush, everything with H is actually handle for an opaque pointer to some of window object. So this is the recurring pattern when you are building a Windows app. It is Windows is a sea of objects. Background color is a object, and that object is pointed to some opaque pointers called handle. That's everywhere. Everywhere in this works like that. And after that, after we fill out the window class structure, then we register that, and if there is an error, then basically we just warning up, right? And so that about registering windows. After registering windows class, we create a window with this API, create window X, which basically create a window, this new API for Windows 2, which basically add new parameters like this. The first parameters didn't exist on Windows 33 point on Windows 3.1, but this exists on Win 32, Windows 95 onwards. So then we tell that we want to create a window with this class, and then we tell what is the caption on top of the window, and then what kind of window we are building, and then the X, Y, and then width and height. And the other parameters needs to be put are the menu, accelerators, and whatnot. Let's see. Let's push F1 and see what was that. Okay, create window X. So parent, we don't have any parent, so we put null. Menu, we don't have any menu yet, so we just put null too. We don't have any parameter like the topmost window, which is the parent is the desktop itself. And then the last one is the lb void lp param. This is a window for window creation data, which if we want to pass some data during creation, then we can put there. But no, we don't have any, so we just use null. The only parameter that we fill is H instance, which point out to our application instance. After being created, we check if we are successful when creating window, and if we are not successful, then we just show the error and unregister class. If we successful, then we show it. And then my favorite part, the event loop or message spam or message loop. So basically, whenever we run this window, there is an infinite loop going on, which tells what happened in this. Whenever I click this, actually a message being generated and being thrown to the window procedure, right? So this is the translate message, means that it will translate a message and dispatch message. These two always here. I will explain later. And then if get message, if they don't get any more message, then we quit by unregistering the class, and then we return the W param. Just in case if we are closing out we close a little bit early. So what happened here is this is the callback or event handler. If you are using JavaScript, you might be very familiar with this one, which may be the thing that is wonky is this what does it mean? Long result callback. It's actually just an artifact from the past, which means that it returns 32-bit values, and it is a standard call again. And also it will take window handle, message number, word param, and long param. Word param is integer 16, and long param is integer 32, which then we basically switch out. We switch this message. If we destroy the window, then we post a quit message with 0 as the value of quitting. So 0 means successful. So whenever we use this and we close, which means that we destroy, then it will quit cleanly. So whenever and then if there is a request to WM pin, remember during when we move this, then the window operating system will redraw, and then when it redraws everything, and then after that they ask our window browser what else we want to redraw. Then we tell we want to redraw what is in on paint, which basically just doing this. It's only set up some rectangle, some HDC, which actually a handle to device context. See, it happens again. So there is a device context is some canvas to write. That's it. That is what I can tell you. What is NC? It's a canvas. And then we say, okay, SDC, we want to paint, and we get the client rect, the rectangle, and we draw the text. That's it. It is not complicated at all. This is the SNPrintf is just to show the minor, major, and OS version. This is not. This is actually built on the Windows API itself. Okay, so if there is no more message that is being handled, then we tell Windows to just give us your default message processor, right? So we run dev window proc, which basically, if we open this, dev window proc means that we function the call default window procedure to provide default processing or any window message that is applicable not processed. For example, if we want to block see, like we want to just block close, yeah, and we don't destroy the window during if we close it. This is bad, but just to show you how it works. So whenever we get the close, we don't close the window. That's it. So the window will stay because it's not processed. We just ignore it, right? So that why we cannot close this window. See, cannot be closed because we ignore the close message. I will get back on that one, how to stop this thing. I'm sorry, but then okay. All right, so I think I need to do something else. So basically, if we want to close, then if we remove that, then we are again send error because it is being run, yeah, and we cannot kill it. Let me, oh yeah, we kill, okay. Oh shoot, I'm killing a wrong task. Shoot, wrong something. Oh no. Alright, I fucked up. Okay, so okay, we force quit. Okay, force quit. Not Visual Basics, I want, sorry. Okay, sorry for that. Let's continue to the Visual C. Wait for it. It is 16 megabytes computer. Okay. Sorry. Okay, we're back. So we fix the close button. So we run it again, and then it means that we are able to close it again, right? So whenever we close, then the dev window proc will basically destroy the window, and then because it destroyed, then we say that we want to quit, and then after that we exit the main class. That's it. It's not bad. It is around 107 line of code to run this thing. And to close it off, this is how we continue, and we start a baseline on this. In the after that, I will create some resemblance of Notepad, when you can create a text editor that you can write inside. The difference is that I will try to make the Notepad is become able to handle a big file, which is not happening even if you are using Windows 11. Okay, that's it. Thank you for joining. Thank you for listening my demo. And then see you next time. Goodbye. Oh yeah, don't forget, like and subscribe. Once again, goodbye.